Welcome back to the video lecture series of fluid machinery. In this session, let us discuss about the discharge through a reciprocating pump and work done by the reciprocating pump. Here, let us start with the discharge through a single acting reciprocating pump. Here, you can see that a single acting reciprocating pump, when the crank rotates, the piston will move to and fro inside the cylinder. Okay, the quantity of water entering into the cylinder will be the volume of the cylinder itself, that is area of cross section into the length of stroke. That will be the volume of water entering into the cylinder and leaving from the cylinder. Okay, the leaving from the cylinder will be the discharge, that is sweep volume is the discharge. Okay, so we need the discharge through the pump per second. So N is the rotation of the crank in RPM, rotation per minute. So we need the discharge through the pump per second, so that we divide by 60, so that we will get the discharge through the pump per second. Okay, suppose the rotation per minute is 60 by 60 is 1, that is ഒരു സെക്കൻഡിൽ ഒരു റൊട്ടേഷൻ എന്ന രീതിയിൽ. Suppose if it is more, we just divide by 60, so that length of stroke into area of piston into N by 60 will be the theoretical discharge. And the next is the discharge through a double acting reciprocating pump. Okay, here you can see that during the motion of the piston from left extreme to the right extreme, the water will enter through the left suction pipe and water will leave through the right delivery pipe. And when the piston is moving from right end to the left extreme, the right suction pipe will suck the water, or the left delivery pipe will deliver the water. Okay, here you can see that one obstruction is here, that is the area of piston rod is here. So when the piston is moving from left to right, the volume of water delivering through right delivery pipe will be less than actually we are getting from the left side, because here is an obstruction, that is we have to reduce this area. Okay, that is here on the right side, A minus area of piston into ln by 60 the discharge. Actually we are getting from the right side, left side in the ln by 60, so that and sum total discharge. Okay, double acting total discharge. So we can rewrite like this: Q theoretic is equal to 2A minus AP ln by 60. Okay, so if we are neglecting the area of the piston rod, we can rewrite as ln by 60 into 2, that is single acting into twice ആയിരിക്കും double acting il കിട്ടുന്ന discharge per second. That is discharge of a double acting reciprocating pump is twice than that of a single acting reciprocating pump. As we know, always the actual discharge will be less than the theoretical discharge. And next is the work done by the reciprocating pump. As we know, the mass flow rate is equal to rho Q or rho AV. The weight of the liquid delivered per second is equal to, that is mg, that is mass into G. That is why rho Q into G. As we know, work done per second is weight of water lifted per second into total height through which the liquid is lifted. Okay, എത്രത്തോളം ഹൈറ്റിലേക്ക് വാട്ടർ കൊണ്ടുപോകണമോ into weight of water, right? That is the work done per second. Okay, so weight W into HS plus HD is the total height, that is section and delivery heads. Okay, so weight W is equal to rho GQ, so that rho GQ H is the work done per second, that is Q is ln by 60 for single acting reciprocating pump, so that work done per second is equal to rho G ln by 60 into H. Or we can rewrite as work done per second, that is equal to power in kilowatts. We can write as rho G LAN by 60 HS plus HT divided by 1000, that is 6 kilowatt like ആക്കാൻ വേണ്ടിയിട്ടാണ് ഈ 1000 കൊണ്ട് ഡിവൈഡ് ചെയ്തേക്കുന്നത്. Okay, And the next term is slip. Actually, slip is the difference between theoretical discharge and actual discharge. Theoretical discharge minus actual discharge is the slip. Okay, when we are switching on the motor, the power produced by the motor is transmitted to the crankshaft arrangement by means of a belt. അവിടെ എന്തുണ്ടാകാം somewhat losses ഉണ്ടാകാം. Okay, that term is called slip. Okay, അതുകൊണ്ടാണ് നമുക്ക് അവിടെ ഉണ്ടാകുന്ന ലോസ് എല്ലാം കൂടെ നമുക്ക് മാറ്റിയിട്ട് എന്ത് പറയാം, തിയററ്റിക്കൽ ഡിസ്ചാർജിൽ നിന്നും ആക്ച്വൽ ഡിസ്ചാർജ് മൈനസ് ചെയ്യുമ്പോൾ കിട്ടുന്ന ടേം ആയിട്ട് സ്ലിപ്പ് എന്ന് പറയാം. ഓക്കെ, അതിൻ്റെ പെർസെൻറ്റേജ് ഓഫ് സ്ലിപ്പ് ഈസ് ദി Q theoretical minus Q actual divided by Q theoretical into 100. This is the percentage of slip. One another term is there, negative slip, as the name indicates that the negative value of slip. That is, here you can see that the difference between Q theoretical minus Q actual is the slip. So when the value of QA will be greater than Q theoretical, we will get minus value. Okay, so since we get negative value for the slip, we can call it as negative slip. It is not always that the actual discharge is lesser than the theoretical discharge. In case of a reciprocating pump, the long suction pipe, short delivery pipe, and running at a high speed, the inertia force in the suction pipe becomes large as compared to the pressure force on the outside of the delivery valve. The suction pipe in the length കൂടുതലും ഡെലിവറി പൈപ്പിൻ്റെ ലെങ്ത് കുറവും ഹൈ സ്പീഡിൽ റൺ ചെയ്യുമ്പോഴത്തേക്ക് ഇനേഷ്യ ഫോഴ്സ് സക്ഷൻ പൈപ്പിലുള്ള ഇനേഷ്യ ഫോഴ്സ് കൂടുതലായിരിക്കും. സോ ദാറ്റ് ഡെലിവറി വാൽവിൽ ഉള്ള ഔട്ട്സൈഡ് ദ ഡെലിവറി വാൽവ് ഉള്ള പ്രഷറും ഇതിനകത്തുള്ള പ്രഷറും തമ്മിൽ നല്ല ഡിഫറൻസ് ഉണ്ടായിരിക്കും, അകത്തെന്തായിരിക്കും നല്ല കൂടുതലായിരിക്കും ഈ കണ്ടീഷനിൽ. സോ ദാറ്റ് ദിസ് opens the delivery valve even before the piston has completed its suction stroke. So suction stroke complete ആവുന്നതിന് മുമ്പ് തന്നെ നമ്മുടെ ഡെലിവറി വാൽവ് ഓപ്പൺ ആകാം, അതിൽ കൂടെ വാട്ടർ വെളിയിലേക്ക് വന്നിരിക്കാം. Thus some of the water is pushed into the delivery pipe before the delivery stroke is actually commenced. This way the actual discharge becomes more than the theoretical discharge. Thus the coefficient of discharge increases from 1 and the slip becomes negative. So let us do one problem. A single acting reciprocating pump running at 60 rpm delivers a 0.53 meter cube of water per minute. The diameter of the piston is 200 mm and stroke length is 300 mm. The suction and delivery heads are 4 meter and 12 meter respectively. Determine the theoretical discharge, coefficient of discharge, percentage slip of the pump, and power required to run the pump. As we know, the theoretical discharge equation for theoretical is equal to Ln by 60. So area is pi by 4 d square, since it is a cross section area. So that since the diameter of the piston is given as 200 mm, we converted into meter, so that we got 0.0314 meter square. So Q theoretical we got as 0.00942 meter cube per second. So നമ്മൾ എന്ത് ചെയ്തു, ലിറ്ററിലേക്ക് കൺവേർട്ട് ചെയ്തു, ലിറ്റർ പെർ സെക്കൻഡിലേക്ക് കൺവേർട്ട് ചെയ്യാൻ എന്ത് ചെയ്തു, 1000 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്തു. ഓക്കെ, സോ actual discharge by theoretical discharge is the coefficient of discharge, so that we got as 0.937. Since the actual discharge is given and Q theoretical, we calculated the value of Q theoretical. So percentage of slip is equal to Q theoretical minus Q actual divided by Q theoretical, so we got as 6.623. And the power required to run the pump is rho GQH. As we know, Q we calculated all the values we have, so substitute the value and we got power required to run the pump as 1478.56 watts or 1.5 kilowatts. Thank you for watching this video.